Let me see. I've got 5 people here right now. I'll give it a few more minutes for everybody else to join. All right, I'm going to go ahead and get started. All right, so first of all, everyone, please be safe. COVID is real. There have been, at least from what I've counted through the communications I've gotten from Shaw, there have been at least 6 confirmed cases on campus in the past 2 weeks. So just be safe. Continue taking the necessary precautions if you can. And as a result of those confirmed cases, in-person classes are shifting online this week. So on Friday, I will not be on campus. I'm forced to do it from home. The next announcement is there's a Red Hat resume building event coming up on October, I believe, either 20th or 21st, so next week. Open to the entire campus. They'll be helping you build your resume, or at least flushing out your resume for future employment. A really good event. I would encourage you all to take advantage of it. The next announcement, on October 30th, during class, Red Hat will be coming out and giving us a talk on open source software and technologies and how you can get involved with open source. Again, I encourage you to take advantage of that event. It will be during class, so as long as you show up, you will be in attendance. And it's going to be a really good talk just about, open source and what it is, how it affects our daily lives, and how impactful it is on just a sheer scale, right? It's Linux, which is an open source operating system we worked with a little bit in this class, is one of the prevailing operating systems for most web servers. So most websites, apps that you use are probably running some type of Linux in the back end. So really good talk. The last announcement regarding Red Hat, their internships are opening up to apply starting mid-November, okay? So if you are interested in an internship with Red Hat, Make sure you're on the lookout for that. I will update you with more information as that becomes available. They're particularly looking for people with strong resumes. So that resume event is important that you attend. Passion and enthusiasm for the potential work that you'll be doing. If it's artificial intelligence, are you really interested in artificial intelligence? If it's data science, are you interested in data science? If it is coding, are you really interested in coding? So they're just looking for enthused individuals, and show some type of initiative outside of class. So what projects have you worked on outside of class in your personal time? Things like that. So again, those will be opened up around mid-November, so be on the lookout for that. Anybody have any questions about any of those announcements? If not, I will continue with the lecture. All right. All right, so we're still on methods. And if you remember last time, we talked about methods, and this time we'll be talking about code organization. I discussed it briefly last time, why methods are so important for code organization, because you can combine code that has a similar objective into a method. It just makes your program look a little bit cleaner. There's something called method overloading, where you can have the same name for multiple methods, but different formal parameters. And you would use that if your method is doing the same thing, but different objects are required when running that method. And then last thing we'll talk about is variable scope. So as you define or declare variables within your program, it has a scope, meaning you can use it in certain places in that program. We'll talk about that today. Okay, code organization. Again, as we discussed last time, methods help to organize code based on similar objectives. For example, to get the max from a list of numbers, to compute the average of a list of numbers, right? There are many different reasons for a method, and there's many different situations or different objectives within code that you can put into a method just to make your program look a little bit cleaner, right? So for example, if we look at this example right here, what is this doing? All right, if you think back to last class, you remember, hold on one second, just real quick. Let me turn this on for you. All right. If you remember, this line right here, this creates a list of numbers. We'll talk about that next week, exactly what that's doing or what that is. It's an array. But just for right now, just know this creates a list of numbers, 3, 5, 6, 8, and 6, okay? And so the next thing I'm trying to do here is int max equals integer.min value. I'm setting this variable max equal to the lowest possible value. Actually, I think I go through this, yes. So this line creates an array or a list of numbers. This line right here creates a variable max and sets it equal to the smallest possible number. It's like -2 billion or something like that. And we do that because we're looking for the max. So anything higher than that, we know is going to be a greater number, and we're going to replace that variable as we run through our code. All right, this line right here, you see a for loop, and what we're using this for loop for is to loop through our list or array of numbers. This line right here creates a variable, a temporary variable, an integer, and sets it equal to the number at whatever index inside that list. All right, index 0, index 1, index 2, which would correspond to 3, 5, 6, 8, and 6. We're just looping through the array, and we're setting it equal, this variable equal to whatever number is at that position. This right here is checking if that temporary number is greater than our current max, right? We want to set our current max equal to that temporary number, right? So we're finding the biggest number within that list. And then lastly, we're printing out that max value, all right? This code works, no problem. It's all within our main method up here, and you see it works. But if you had to do this over and over again, so what if we have another list and need to find the max of that list as well? we'd have to copy and paste all that code for that new list. Or what if we have more code within our main method that does a lot of other things? That main method would become very complex and long. And so what we can do is put that code in a new method. So all this code right here, take that code. It has a clear defined objective, which is to calculate the max of an array or a list. We take that and we put it inside a method. Right? Public static int max. It takes in a list of numbers right here, calculates that max number, and returns it back up to our main. And so now if you look at our main method, it's a lot cleaner, right? And it's easier understood. First, we create a list. Then we find the largest number in that list, calling our method max. And then we print out that max. And this actually should be largest number right here. So let me change that. And then we print out that largest number that we got. All right, so it just makes your code a little bit cleaner, a little bit more concise, and it shrinks the size of your main method. Again, you don't want everything inside your main method, just the main method to run and call different methods from there. All right, questions about code organization and why we create methods. Again, if you have a question, you can put it in the chat as a private message to me, or email me, or we can set up office hours if this doesn't make sense at all. All right. Method overloading. Again, like I said before, you can have two methods which share the same name, and maybe they have the same, there's a reason for that because they do the same thing, but they have different formal parameters, right? So my example I gave you is we have our first method that we just used, max, which returns the max number from a list of numbers, right? Very simple, straightforward. Well, say we want to do the same thing, but with two lists of numbers, right? We can create another method with the same name, but different formal parameters, right? And the program, depending on which one you use, however many parameters, actual parameters you use, the program will determine which one to call. And we'll go through an example of this. So again, this is our first method, returns the largest number in a list of numbers. We call it up there. We call it up here. And it works no problem, like we just did in the previous example. However, if we move on, let's say I have two methods now, right? I have the first one up here. This is the same one that we had before. It has one formal parameter. But now we have a second method down here, which has two formal parameters, which are two lists. And it returns the largest number from those two lists. And that's all I'm doing right here. I have my max. I set it equal to the minimum again. I run through, and I pretty much just copied and pasted that for loop twice. And whatever that final max is will be the max between those two lists. And this, I see a couple typos, so this should be numbers 1, and this should be numbers 2. All right. So pretty much the same thing as the original max, but now we're doing it with two formal parameters. And again, method overloading is just you can have the same name, the same method name, but different formal parameters depending on what you're doing. And if we make this call up here, int largest number equals max list 1, the program understands you are calling the first method with only one formal parameter, right? Our actual parameter is list 1, and it knows, okay, they only put in one actual parameter. So we'll use the first method that only has one formal parameter, okay? Which is that method right there. All right, but what if we have this right here? We have two lists, And then we say int largest number equals max, and then we have two actual parameters, right? The program understands you're calling the second method, sorry, with two formal parameters, which is down here, because you have two actual parameters. And let me fix that. Right. Because you put two actual parameters down here, the program automatically knows you're not using the first one because that only has one form parameter. We're going to use that second one with two form parameters. Okay. So method overloading, again, you can have multiple methods with the same exact name, but your form parameters must be different. If the form parameters are exactly the same, you will get an error. But if your methods have the same name and different formal parameters, you're good to go. And you can use them in different circumstances. All right. Any questions so far? We talked about code organization and method overloading and why. Okay, well, I'll continue. All right, variable scope. So again, variables have scopes depending on what block of code they were created in or declared in, right? So for example, down here, class variables can be used within the entire class block. Method variables can only be used within that specific method. Loop variables can only be used within that specific loop block. If and switch statement variables, again, can only be used within those specific if switch blocks. So let's go through this. So say we have this class variable, int count up here. That's a class variable we created right underneath our class and not inside any of these methods, right? That means that int count can be used within the entire class, right? Anywhere in this class, we can use it. So we use it here in the main method and in our max method. Don't connect this to our previous examples. I'm just using this. But we can use count anywhere inside those methods, and we don't have to redeclare it, right? We could use it inside our main. We could use it inside our max. If we had another method down here, we could use it down there as well. It can be used throughout the entire class, right? Because we created it outside of methods. It's inside these class blocks, right? These class blocks up here, we can use it anywhere inside that class. Now, method variables can only be used within the method block. So if you see here, we created this int count inside our main method. Then we're doing some things with count right here. So it can only be used within that main method block in those opening and closing brackets. So only within that main method, right? That is not allowed because we didn't create count as a class variable, so we can't just automatically use it down here. We would have to declare a new count if we wanted to do that. Again, this variable can only be used within the method it was created or declared. And that's what we're doing here. All right, now loops. Again, if I create a variable inside a loop, it can only be used inside that loop. So if we look here, this is similar to the code we had before. Do some code. Int main max equals, we call our method here, and we pass over a list. We go down to this method. We have our max equals integer.min value, and temp equals numbers. That should be I. If temp is greater than max, max equals temp. So this variable temp can only be used inside this loop, right? I cannot use that outside that loop. And here are the opening and closing brackets, can only be used inside that loop. Outside this loop, I cannot use temp, right? Can only be used inside the loop it was declared. So we can't do something like this. We can't use temp out here without redeclaring it, okay? We can declare a new temp, but we wouldn't be able to just use the variable out here and do something like this. That's not allowed. All right. Now, if statements. So let's say I have the same method and everything, except now I have a Boolean inside of an if statement. Boolean changed equals true, right? Again, it can only be used inside that if statement it was declared in. So only inside that if statement. We can't do something like this. That's not allowed, right? Change can only be used inside the if statement it was created. All right, so now let's go over some examples with actual code. Any questions so far? Lecture 15. All right. Okay, so let's just do that example we had before. So let's create a list or an array. All right, we create our list. Now let's find the max. Well, actually, you know what? Let's calculate the average of this list, not the max. Let's do the average. So let's do a double average equals 0 and double sum equals 0, right? We know our average is going to be our sum divided by the number of numbers that we have, the total number of numbers. So the first thing we need to do is loop through this entire list and add all of these numbers up. So 4 and I equals 0. I is less than list1 dot length I plus plus. And then we do int temp equals list1 at position I. Right, and that just gets whatever number is at 0, 1, 2, and I'll run through this and you'll see that changing. And then we just do sum plus equal temp. And that'll add that number to sum. Then our last step is average equals, let's cast this into a double, sum divided by list1 dot length, which is the total number of numbers. And let's print out our average. System.out.println average plus average, right? So again, if I look at this code, this first line right here, it creates a list of numbers. I'm creating two variables, average and sum. I'm setting both those equal to 0. This code right here is a for loop to loop through our list, and we're setting this variable temp equal to whatever number is at that current index. And then we're just adding temp to our sum. We're just counting up or summing up all of our numbers. Down here, I'm saying average equals, I'm converting this sum into a double because right now they're all integers, right? And I'm dividing by list.length, which is the total number of items within our list. And it's system.out.println, I'm printing the average. So let's run this. I'm going to debug it. All right. Stops at the first line. If we look at our variables down here, we don't have anything yet. So I step over. Now we have a list of numbers, right? Same list that we have up here. So now we actually have it in our code down here. I create an average, set equal to 0.0, and a sum equal to 0.0. Actually, now I look at this, I don't actually need that line right there because I did declare sum as a double. We go into our for loop. It's going to loop through. And again, set temp equal to whatever number is at index I. So right now, I is equal to 0. So the first index in our list at index 0 is indeed 5. So temp will equal 5 down here. And we just add that to our sum. And so you now sum equals 5. And we do this process over and over again until we ran through our entire list. All right. We just keep going. Temp is going to change each time, and then we finish, right? So now if you look down here, our total sum is 11,728. That's our total sum. We compute the average, which is now 1,675, and then we print it out. And you see it right here, 1,675. All right, this works, right? No problem. But what if I have another list of numbers? What if I have another list? I have int list 2 equals new int 6, whatever numbers we want to put in here. All right. And I want to compute the average of this as well. I'd have to copy all of this, Control C, and paste it down here. We've already declared these, so I'll get rid of that. This would need to be list 2, list 2. This should be list 2 as well. And then I would print out the average again. All right. But as you can already see, our main method, let me zoom out a little bit. Our main method has a lot of code and a lot of redundant code, right? But we don't necessarily want this redundant code in here. Right? It makes our main a little bit more confusing and, again, redundant. So let's delete this, right? Let's delete that, and let's put all of this inside of a method. And that way we can just call a method and get the same results. So public static double compute average. And it's gonna take in a list of numbers as its formal parameters. All right. So now all we have to do is call that method one time. I named this number, so I need to change this down here. And now all I have to do is return average. All right. And so now we have our method. Our method does the same exact thing with a list of numbers, and it just computes the average and returns it back. Not only does this make our main method look better, it also organizes our code a little bit better, because now I look at this method and I know exactly what this method is supposed to be doing. It's supposed to be computing the average or something. Again, if I add in comments, it makes it even clearer. So up here, I can do double list 1 AVG equals compute average list 1. And I just pass it list 1, and I can print out this right here. And then I can just copy this and paste it down here for list 2. And print out list 2 average. All right, now if you look at our main method, it looks a lot cleaner, right? A lot cleaner. And our compute average, we only have to do this once, write this code once, and we can use it many times. So if I run this, it should compute the average of both of those lists, which they're actually very close to each other. Any questions about this, why we do our code organization? Any at all? I know somebody has a question out there. Well, for those of you that just came to class, my announcements at the beginning of class were to, 1, stay safe out there. There have been 6 confirmed cases on campus in the past 2 weeks of COVID-19. So continue to be safe. I will not be on campus Friday. in-person classes have been transitioned online for this week. There is a resume building event next week through Red Hat, either Tuesday or Wednesday. I'll get you the specific numbers on Friday. Also, let's see. Also, on October 30th in class, there will be a Red Hat open source talk. And starting mid-November, Red Hat will start opening up their internships. So they're looking for Shaw students. So we want you all to apply. You have a strong chance of getting that, but I encourage you to attend the resume drive or resume event to build up your resume. All right. So now let's continue to our next topic, which is method overloading. So I have this method. It computes the average of a list of numbers, right? Well, how about, let's say I want to compute the average, but instead of a list of numbers, I just want to pass in 3 numbers and compute the average of those 3 numbers. I don't want a whole list. It's only going to be 3 numbers. So I can do the same thing, public, static, double, compute average, right? And if I do int numbers again, I'm going to get an error. I already have it. It's already defined. But I can do this. num1, num2, num3. Right? And you see that error goes away. This is still an error because it's looking for a return. I haven't returned anything yet. But as you can see, this works now. I have overloaded this method. It has the same exact name with different formal parameters. So I can do double sum equals 0, sum plus equal num1 plus num2 plus num3. And that just adds all of those numbers up to sum. Then double average equals sum divided by 3. Return average. Right? And now this does the same thing. It computes the average, but you see the code inside here is a little bit different and our formal parameters are different. But at the end of the day, I'm still trying to compute average. Right? It has the same objective as the code up here, but with different parameters. This computes the average of 2 lists, which we called up here. And now let's do this. Double num1 equals this right here. Double num2 equals that right there. And double num3. And actually, you know what? Let's read this in from the console. Let's not write this in. Scanner scan equals new scanner system.in. Control-Shift-I. Let's move this up a little bit. All right. All right, now double num1 equals input.next double. All right, let's read this in from the console. Double num2 equals input.next double again. And double num3 equals input.next double. All right, so what we did here is we created a scanner and read 3 numbers from console. All right. Up here, we created 2 lists and computed their averages. All right, we read in those 3 numbers from the console. So let's compute the average of those 3 numbers. Double AVG equals compute average num1, num2, and num3. And you see here, these parameters, these actual parameters are different than up here. And so the program will know which method to call. It's not going to call the one with the list. It's going to call the one with the 3 numbers. However, I can't put in another number, double num4, or I can't just put in another number here. I don't have a method that takes in 4 numbers. It only takes in 3. All right. And then system.out.println. All right. And I print out that average. So let's run through this. Let's see what's going on. Let's debug it. So we get down here and you see we've already computed the average of those 2 lists up here. So those have already been done. I put my break statement right here. So my break statement, it created the scanner and now it's waiting on me to enter in a number. So I'm going to enter in this number right here. And then it's waiting on me again. Let me enter in a number. And then it's waiting on me again. Let me enter in a number. All right. Now we get down here, double average equals compute average. Let's step into this method so we see which one it's actually going to. Is it going to this one or is it going to this one down here? Step in and you see now it's going down here. It's going down to our second method with the correct formal parameters. We step over, we set sum equal to all those numbers combined. We see down here. We compute our average, which is right here, actually up here. And then we return that average. It takes us back up here. We set AVG equal to that, which is right here. And then we print it out. And you see the average from 3 numbers to actually 226,136.4536. And that's method overloading. Again, you can have the same name for 2 different methods, but your formal parameters must differ. And you would do this because you want your methods to do the same thing, right? This one is computing the average. This one is computing the average. But we have different form parameters we want to put into this method. This one up here, we want to take a list. However, this one down here, we just want 3 numbers, right? So that's method overloading at its core. And then lastly, we'll talk about variable scope. So variable scope refers to where a variable is created is where you can use it. So let me show you a class variable. Int count equals 0. This would be a class variable. I created it inside my class block, but I didn't create it inside a method. Right? I didn't create it in any of these methods. But since I created it in the class block, I can use it anywhere in this entire class. So right here, I'm going to do count plus plus. And that should, hold on. Okay, yep. It needs to be static, just like if I want to use it inside the main method is static. So this variable must be static if I want to use it inside the main method. And you'll notice that a variable is a class variable in NetBeans if it turns green. If that variable is green, it's a class variable. So I can use it anywhere in this class. I can do it down here if I want. I can do it down here. All right, it's a class variable. I can use it anywhere in my class because I created right inside the class block and not inside any of these methods. However, if I do this, int count equals 0, inside my main method, you'll see int count equals 0, count plus plus. I'm using count, no problem. However, I'm going to get errors down here because a count was not created inside this method. right? If I wanted to do this, I would have to create a new count variable down here, right? But I can't just use it down here since I created it inside my main method and it only has scope within that main method, right? All right, so that is class variables and method variables. Let's talk about for loop and while loop variables. So if you go to our compute average, right, our compute average method right here computes the average of a list of numbers. We have this variable int temp equals numbers I, right, which is essentially just saying temp is going to equal whatever number is at index I. Okay? Well, we created this temp inside this for loop, so we cannot do something like this, temp plus equal, right? Temp has no scope out here. It's only scoped within this for loop. We can't use it out here. We'd have to create or instantiate temp or declare temp out here. We can't do plus equal if we wanted to use a variable called temp out here. I could do something like this though. I could do this, int temp equals 0 up here, not declared in here, right? Now this temp has scope within this entire method. So I can use temp anywhere in this method. I can use it up here, inside the for loop, after the for loop. It doesn't matter. Temp now has scope inside this entire method, okay? However, if we declare it inside the for loop, like we have here, it only has scope within the for loop. And the same thing applies for if statements. If temp is greater than 5, int new number equals 7, right? Just some simple code. If temp is greater than 5, I just created a new number and set it equal to 7. Well, this new number, this variable right here, only has scope within the if statement. I cannot do new number plus plus out here. I'm going to get an error. It doesn't have scope outside of this if statement. All right. So that's pretty much all the concepts we were talking about today. We discussed code organization, method overloading, and variable scope. Any questions? Questions at all?
Are you going to upload this lecture to the class website?
I am.
Okay, thank you.
Yep. All right, if there's no other questions, that'll do it for today.